Learning Objective 2 from Section 5.5 is to calculate and interpret the probability of a compound event using the multiplication rule. There are actually two versions of the multiplication rule, which I have written down here. The probability of A and B equals the probability of A times the probability of B, or the probability of A and B equals the probability of B times the probability of A given B. Notice that both of these are for AND probabilities. A compound event means that I have more than one outcome that I need to be considering together with other outcomes. So I want event A and event B to be happening at the same time. What's the difference between these two formulas? The difference is whether the events are independent, in which case we'll use the first formula, or whether they are dependent. The second formula is also called the general multiplication rule. It actually can be used, but also for independent events, because if two events are independent, then the probability of A given B is just equal to the probability of A. Remember that independent events happen when knowing that event B occurred does not change the probability that event A occurred. So that second quantity here, the probability of A given B, just becomes the probability of A if our two events are independent. All right, but it's often easiest to just think about these as two separate formulas and consider whether you have independent or dependent events. So let's look at the first example. What is the probability that two randomly selected flights are both delayed? We're going to use this data that's given to us, submitted to the U.S. Department of Transportation, showing the on-time and delayed flights for Alaska Airlines for several cities. This question, part 1, says, assume flights are selected with replacement. So I have two flights that I need to consider. The first flight needs to be delayed. There are 501 delayed flights in the table out of 3,775 total flights. So that's the probability for my first flight. Once I've selected one of those flights, I'm going to replace that flight, which means that my table hasn't changed. So the second probability is going to be the same thing, 501 out of 3775. So in other words, I can just square this probability to compute this probability of A and B occurring. Let's use GeoGebra to do this calculation. I'm going to bring out a parenthesis, and I'm going to enter in 501 divided by 3775. And then I'm going to come outside, and I'm going to use this squared option. And then I will click on this approximately equal so I can convert it to a decimal, and I get 0.018 rounded to 3 decimal places. Let's look at the next example. What is the probability that two randomly selected flights are both in Seattle and delayed? Assume the flights are selected with replacement. So now I'm going to look at the group that are in Seattle and delayed. There are 305 of those flights, and I'm going to put that over the total number of flights, again 3775. And now once I've selected this first flight, I'm going to replace it, and I want the second flight also to be in Seattle and delayed. So again, I can just square this fraction to give me the probability of this compound event. So this time we will calculate 305 divided by 3775, and we will square that, and then we will convert it to a decimal, and we get 0.007. rounded to 3 decimal places. All right, one more example, part 3. What is the probability that two randomly selected flights are both in Seattle and on time? Now assume the flights are selected without replacement. Okay, so for our first flight, we want it to be in Seattle and on time. There are 1841 of those flights. And we'll divide again by 3775. But now I am not replacing that flight. So one of those flights has now been removed out of the table of data. So I no longer have 1841. Now I only have 1840 to select from for my second flight that needs to be in Seattle and on time. And because I've removed a flight, my total is now 3774. In this case, I'm using the second multiplication rule because these are dependent events. When you select without replacement, the events are dependent. And so therefore my second fraction there is a conditional probability, conditioning on the fact that I've already removed one of those flights in the on time and Alaska cell. So I can do this calculation. I'm going to type in my first fraction, 1841 out of 3775, and then I'll type in my second fraction, which is 1840 divided by 3774. I'm multiplying those two together to use the multiplication rule, the general multiplication rule, and I'll convert this to a decimal and I get 0.238. To compute this probability of A and B occurring when they are dependent.